Hello, everyone. This is Pat at Maendeleolab, and this is where the fun begins. In this tutorial, we are creating VPCs from a script. Tasks, we're going to set up the environment. We're going to download the repo, deploy VPC resources. We'll verify that we have deployed them successfully, and then we'll finish up by deleting those VPCs. In the description section, I have shared the link to this GitHub repository, Maendeleolab VPC. And if you have already watched the previous tutorials on setting up the environment, those are the prerequisites. You can use this on any Linux distribution. You need to have Python 3.6.9 or higher installed. AWS CLI version 2 must be installed. And those are the main, requirements. If you remember this instance, in the previous tutorial, we made sure that it was able to make API call, right? And yes, it can still return the buckets. So I'm going to create a folder. I named it that. I'm going to cd into it. You can see there's nothing there. And I'm going to come back here, and here, this is important. It's very important to do this. So I'm copying this, but I definitely advise you not to copy it. You have to understand what this means. So we are creating a variable that is pointing at this folder. This is the example. And this variable is basically sets up the environment. It means that anywhere this variable gets referenced on your system is going to assume that you are going to this particular folder. So in my case, I created a folder. In your case, you may not want to create a folder, it's fine. But this is important. Wherever you decide to clone, because what's going to happen, we need to clone this somewhere on the instance. So for me, I need to clone it inside this folder. I want to know the path. So now I have the full path. What I need to do, I'm going to do this and replace it with this, basically. So this is what you need to do as well. And then once I do this, the next thing I need to do is to verify that that variable is now available. I'm going to do this. Of course, I'm going to take this output out because I don't want to share my IP address. And let's take a look. And there it is. You can see it is there. We're good to go. The very next thing we need to do is now walk through. So this is the walkthrough, and this is where the fun begins. Very first thing we do is to clone this. Right, so we cloned one CD there, and see that all the files listed in this repo are there, which is good. And the very next thing is really the focus, which is this. The whole reason for creating this was for simplicity. And let me just spend a couple minutes on the structure of this repository. So you have this, of course, license. I'm not going to go over that. I'm not going to go over README. You should know about that. But the build VPC.py is the main. And in here, this is where I am basically saving a lot of the functions. And those functions are basically API calls. And I'm using Python to leverage, to make them reusable, basically. So I want to reuse these API calls over and over, wherever and whenever I choose to. So I created functions specific to particular tasks that I want to perform, and they're all listed here. Verify VPC, or make a VPC, update VPC, get VPC ID, destroy, erase, all that good stuff. I can always add more. API calls to this, and very easy to manage. So this is a decoupled approach. This is now, if you think about this, this is very specific to VPC only. It's not concerning about subnets, route tables, or anything else. This is very focused on VPC. From this point on, I can add more features without causing issues elsewhere because the functions, I can test them. They are reusable, very good stuff. And this is something that as a user, you do not have to worry about. But if you're an advanced user and familiar with Python syntax, you can come here and take a hack at it, make it whatever you want. And I'm going to come back here at the top. Remember, our variable is right there, it's referenced there. This means that now when we call our variable, it is going to reference the folder where we have the repository downloaded, and that's what we want. And here's where the magic happens, is in this file. And this is where all of you users, anyone right now watching this, this is the only file that you're concerned about. And here in this file, I have a CIDR list, right? This CIDR is for US East 1. This one is for US East 2. And this is the primary CIDR. I have a secondary CIDR list. With VPC, you can provision additional CIDRs. And same thing, this one is for US East 1, and this one is for US East 2. I have my regions list there. And here I can call the functions that I have into the other file, build VPC. I can call them here to do things. And here I'm creating a VPC named network dev one. This name, network dev one, is going to be deployed in US East 1 and US East 2. The difference is each gonna have different CIDR blocks, but same name. Just like in your case, you may have a VPC that's doing named dev in US East 1 and another VPC named dev but in EUS 1. They both have the same functionality, but in two different regions. You can do that. It's really a nice way to keep things standard. So everything, all the values that you see here, you can change them if you choose to. I think if it's your first time using this, I advise you to just run it as it is, just to see, how it works. If we go to the console now, I'm in US East 1. You can see this is the default VPC. And here as well, default VPC in US East 2. What I want to do is to deploy. So if everything so far looks good, we have not done anything wrong, we should be able to deploy this without a problem. All right, there we go, created one, US East 1, US East 2, adding additional CIDRs. And here we go, that was pretty fast. If I refresh this in Ohio, we have network dev one, the CIDRs are there. If I go to US East 1, same thing, the CIDRs are there. And there's a lot of power with this, which is tagging. It's very important. My scripting relies on this. It's case sensitive and it's idempotent. What does it mean, idempotency? Idempotency, if I have a house named Maendeleolab and it is blue, once it's created and I run the same exact command to create it again, it's going to say, well, I'm not going to create it because it exists already. So that's the beauty of that. And how we verify this is we do the same thing. We run it again to see what happens. So if you can see, it's fully idempotent. It doesn't create it. It tells you there already exists. So this is nice. If I come back here and refresh this to see if we have created anything else, nothing else was created. Same. If I go to USC's 2, nothing else was created. Same. So this is all working. We did set up the environment. We downloaded a repo. We deployed the VPC resources. We verified, right, that it's there. We run it again, and we were not able to deploy any more VPCs because idempotency is really working as it should. The very next step is to delete everything and wrap it up. So one more thing before we go, just wanted to come back to this. This method is not persistent. So when you use this command, as we did, for simplicity, if you're not familiar with Linux, just do it, just follow exactly the steps that I did. But this is not persistent. This means if you reboot the instance, you're going to lose, the variables goes away. You got to do this all over again manually. There are other ways to make sure it becomes persistent. You can do that. It's beyond scope. You can look it up, how to make a variable persistent in Linux. And I'm sure there are a lot of tutorials out there that can help you. So very next, we're going to try to delete this. And that's what we're doing. And again, idempotency is beautiful. The condition for deleting a VPC, there's no dependencies, meaning no route tables, no subnet, no gateway, nothing, nothing associated to that VPC. Once those conditions are met, yes, you can delete it. But if something is associated with it, it is not going to delete it. And this is where I like about scripting. You can basically have a strategy of where you want to spend most of your time. Do you want to write a script to check so many things, or take advantage of under the hood? Because the AWS CLI has idempotency for certain things as well. Like, for example, you can see here dependency violation. When you when calling to delete this, which is the VPC ID for the default VPC in Ohio, it couldn't be deleted because, yes, of course, it had dependencies. There were route tables associated to the VPC and subnets. And this is why I couldn't delete it. And we can verify that going back here first in US East 1. You can see network dev 1 is gone. And here in Ohio, network dev 1 is gone. And this is the VPC ID I was talking about. And you can see it wasn't deleted. So this is just awesome. It's nice. It works fast. I like it. And this is, I'm happy to share with you. Try to play with it. If you run into any bugs, drop in comments. I will be happy to assist you. Next, the very next script or repository will be about subnets. And the key here is stay consistent with your tagging. So for me, I'm going to stay consistent with network dev 1. Although we deleted it, next time eventually I have to build it again. But when we build subnets, we will be referencing this name to create additional subnets for these VPCs. And this is all to it. Tagging is very powerful. And this is how I'm able to script and do things easily. And this is one of the methods which I will use for the subnetting piece. So hopefully you're looking forward for the subnetting. In the meantime, play with this. If you run into anything, just reach out to me. But do what I just did, create it, delete it, have fun with it. Don't be afraid. As you can see, it was very simple to do. And hopefully it is the same for you. I am Pat at Maendeleolab. I hope this was informative. I hope it is making sense. Until next time, stay focused, stay curious, learn, and salut.